After studying this module, you shall be able to learn about the biometry, poroscopy and edgeoscopy. You will also learn about fingerprint pattern at various levels. Forensic science largely concerns the analysis of crime, its existence, the perpetrator and the modus operandi. The science of biometrics has been developing approach that can be used to automatically identify individuals by personal characteristics. Biometrics, poroscopy and edgeoscopy is usually concerned with the recognition of the person based on their physical or behavioral attributes. So far, biometric methods have chiefly used to assure identity. The biometric studies are concerned with the finding of a set of features which provides the least deviation between the different samples of one individual and most separatably between the samples of one person and the rest of population. These features will provide the best chance for individualization. In fingerprint recognition, the most popular and widely used feature are the minutia-based features. Such level of conscience through has not been reached for most of the biometric traits, and the best set of features is subjected to constant examination. Now, let us see the study of fingerprint patterns in various levels. One of the most important purposes of collection of physical evidence is to establish the identity of the suspect. The identification is possible through a variety of evidences. Fingerprints are considered to be one of the best means for personal identification. Any person can make an attempt to change his or her voice or handwriting, but it is impossible to change fingerprints because they are unique. Even the fingerprints of two fingers of the same persons will never match and are permanent in nature. The palmar area of the hand and the plantar area of the feet comprising distal flanges and has the ridged skin and are known as papillary or friction ridge skin. These ridges once formed in the fetal life, they grow in the size and rest will remain unchanged throughout the life and even after the death or till the body is decomposed. If the epidermis is injured, it regrows very swiftly till the injury has not entered deep into the producing layer of the epidermis. The shape of the ridges on the healed surface will be identical with the pattern as it existed prior to the injury. In 1914, Locard published assumptions in relation to the fingerprint identification and the standards which are used to reassure dependability founded upon the statistical analysis. He presented the sum of the given rules, that is, the certainty of identity becomes beyond debate if more than 12 concurring points are existing. If 8 to 12 concurring points are present, then the case is marginal and inevitability of individuality will depend on the clarity of fingerprint, the rarity of its form, the cone and delta in the available part of the print is present, the presence of pores which is also called to be poroscopy, the papillary ridges and the valleys, the direction of lines and the angular value of the junctions, that is Edgeoscopy or edgeoscopy. If lesser number of characteristics are found, then the fingerprint will not provide identification but only an assumption to the number of points available and their clarity. These observations are generalized by Stenenwender in 1958 regarding the value of the 12-point threshold. But in several cases, the fingerprint impression are incomplete, smushed and disconnected or defective due to various reasons, that is, the essential number of rich characteristics are not available. It is a great handicap for expert to give opinion on identity in such cases. In such situations, there is a need to include the third level details, that is, the number, shape and relative position of sweat ports and shape of edges of the ridges. Locard in 1912 considered the ports, that is poroscopy, which is found on the finger ridges, and they are in use in the individualization process. He also understood the importance of the form of edges of the ridges, which are also permanent features like in any ridge characteristic, and is called edgeoscopy. Edgeoscopy, which can be used as a method of personal identification, is the study of characteristic of the edges on the ridges, while poroscopy is the comparison of the sweat pores. The edges features on the side or both sides of ridges with the insufficient Galton details, that is second level details, or ports in their correlative locations are sufficient to prove the identity, which was also said by Chatterjee in 1962. Since very little work is available on the use of edgeoscopy and poroscopy in personal identification, it was thought desirable to make a comprehensive study of partial, smushed or fragmentary fingerprint and set a standard for identification using the first, second and third level details. The outcomes acquired from the above researches are predictable to be supportive in identification, chiefly in those fingerprints in which appropriate number of ridge characteristics or Galton details are not available. Now, let us see a detailed study of poroscopy and edgeoscopy. Fingerprints are the prints formed by papillary ridges at the distal portions or positions of the fingers and thumbs. These ridges of the fingers are formed in 3rd–4th month of the fetal life and accepted for growing in size remain unchanged throughout the life. Prints are generally decisive evidence. Experts' report should consider 3 important possibilities. That is, the subject made the prints, the subject has not made the prints, the print has insufficient details to be evaluated. The patterns formed by the ridges never change throughout a person's life. Criminals that have been often tried to change or destroy their fingerprints, but they always grow back in the exactly same pattern as if damage is so severe enough they are exchanged by the patches of scar tissue which they form recognizable patterns. Now we have the type lines. The 2 deepest ridges which initiate parallel, diverge and cover the incline to cover the pattern area, or when there is a certain break in a type line, the ridge closely outside of it is said to continuous. Based on the patterns formed by the friction ridges in the center of the finger prints, the patterns are classified into 4 categories: arches, loop, whirl and composite. Arches. Arches are the rarest pattern found in the fingerprint. In this pattern, ridge lines flow into the print from one side, rises in the middle and the pattern flow out of the print from the other side. These are further of 2 types, that is plain arches and tented arches. Plain arches, the pattern in which ridges enter from one side of impression and flow or tend to flow towards the other side of impression with slight elevation in the center of the small heel. There is no core, no delta. In tented arches, the pattern in which most of the ridges enter from one side of impression flow towards other side like plain arches, but in the ridges at the center have an upward thrust in the shape of the tent, arranging themselves on the both sides of the spine or axis towards which adjoining ridges converge. Secondly, we have the loops. The patterns in which one or more ridges enters from one side of impression, make a recurve and tend to exit on the same side of impression. In this pattern, there is one delta and one core, and loops further are of two types. Radial loop. The loop pattern flowing towards the radius bone, that is towards the thumb of the hand, is called radial bone, which is rare type of pattern. Ulnar loop. The loop pattern flowing towards the ulnar bone, that is towards the little finger of the hand, is called ulnar loop and have one delta and one core. Next we have the whorls, the pattern in which the ridges recurve in circular manner and at least one ridge makes a complete circuit around the point of core. The whorl pattern must have one core, two delta and a recurring ridge in front of each delta. To confirm the pattern as a whorl, the line joining two deltas must touch or cross at least one recurving ridge in the pattern areas. The whorls may be circular, spiral or oval in nature. Next we have composite pattern. When two or more patterns, either of the same or different types, combine to form one pattern, then the pattern is called as composite pattern. These are further subdivided. That is, first one is central pocket loop, the pattern in which the majority of ridges forms loop and one or more ridge recurring at the core of the pocket. Like whorls, at least one ridge makes one complete circuit about point of core and there are present two deltas. But unlike whorls, the line joining two deltas should not touch or cross any recurving ridge in the pattern area. Next we have lateral pocket loop, the pattern in which there are present two separate and distinct overlapping loops with separate shoulders and two deltas. The core forming ridge of the loop often towards the same side of the deltas. In other words, the core line exists are not divided by deltas. Next we have the twin loop, the pattern in which there are present two separate and distinct overlapping loops with separate shoulders and two deltas. The core forming ridges, core lines of the loop often towards either sides of the deltas. In other words, the core lines exist are divided by deltas. Now we have the accidental pattern, the pattern which is too irregular to be classified in any of the previous pattern is termed as accidental pattern. These patterns consist of combination of two or more than two different types of pattern with two or more deltas. The frequency of loop pattern varies from 65 to 70%. Whorls and composite varies from 25 to 30%. And arches pattern is about 5%, as was said by Chattopadhyay in 1975 and Bandyopadhyay and Drash Sharma in 1995. The pattern arrangement are class characteristics, which forms the first level detail. The overall ridge count and the orientation of the print are other details used in identification process. These characteristics alone do not provide sufficient uniqueness to the print to individualize, although the pattern classification eliminates non-matching pattern and many partial prints found in the criminal investigation are so fragmented that the pattern areas do not show up at all. Thus, identification must be based on more detailed examination of ridge characteristics which are independent of the pattern. This comprises the second level of detail. Some of the features that are studied are ridge ending, bifurcation, dots and closures, islands, bridges, lakes, crossings, etc. If sufficient number of these characteristics are found at their correlative positions in the evidence prints and on prints taken from suspect, that is specimen, and if no difference are seen, the prints are considered to be form of the same finger. Every feature can be recognized in terms of different patterns. its root and its position with respect to other distinguishable features in the print. These two levels of details are sufficient to establish identity of the print, but there are cases in which the print is too blurred or smudged for identification in the usual way, or the impression is so fragmentary that it discloses only very limited number of fresh characteristics. Such prints are chance prints, where variation in condition are so many that some other details, namely third level of details, are examined in such prints. These details include poroscopy and edgeoscopy. French criminologist Edmond Locard discovered the method of establishing identity by comparison of sweat pores, and Palmer and Planter surface are known as poroscopy. These pores appears as a minutiae opening on the mouth of the ducts of sweat glands. Sweat pores have great individual differences and they are persistent throughout the life, an invaluable series of individual features which can be employed to the advantage of criminal investigation in cases where the record is too incomplete to show definite pattern or different fragmentary to make out even the rich detail with certainty. Certain factors such as quantity and quality of the ink used, degree of pressure applied in taking the inked print, or how an article is touched, the smoothness of the friction skin, etc. affects the visibility of the sweat pores. Now, sweat pore studied on the ridges vary in shape of the pore, size of the pores, position of the pores and number of pores per unit area. The opening of sweat glands, that is sweat pores, are arranged on the ridges of the friction skin and they can be various shape, that is triangular, circular, oval, rectangular, etc. They may be placed in the middle or the periphery of the friction ridge. Like fingerprints, the shape of pores and their relative position remains constant throughout life and they are variable in different fingerprints. The size of pores may vary with advancement of age, but their nature and relative position remains constant. Number of pores per unit area can be calculated as the average number of the pores that occur on the given length of the ridge or found within the given area. In the present work, the different features of pores, namely the shape, size, position of the areas of fingers, have been studied in the inked print. Chatterjee in 1962 visioned Edgeoscopy as an identification process where the characteristics of the edges of the ridges of the friction skin would be compared and evaluated. These characteristics are the alignment and shape of the individual ridge unit. The edges of the ridges are so unique and are persistent like ridges and pores. The characteristic of the edges of the ridges do not change during the life of an individual, though their size can vary with advancement of age. Chatterjee in 1962 classified the characteristics of edges of the friction skin into 7 classes, that is the straight edge, convex edge, peaked edge, table edged, pocket edge, concave edge and the angular edge. The types of surface on which these chance print appear and the kind of ink used affects the visibility of these ridges. To sum up, holistic approaches to identification of the friction ridge surface is required. During the identification, experts presently tend to explain and demonstrate the identification only on the basis of numbers and sometimes the type of ridge characteristics. The holistic approach explains and mentions further aspects. Persistence and uniqueness are the foundation on which the science of fingerprint is based. If this is true for a ridge flume and minutiae, it must follow that it also true for other aspects of ridge structure. The manner in which this information is used to identification process is further explained. That is the first level, in which overall pattern arrangement. This does not have sufficient uniqueness to individualize. The pattern formation is probably the first aspect that an expert is using in the identification of fingerprints, but is very rarely mentioned in explaining the identification. For example, if an expert compares a loop pattern mark with a whirl pattern, and if two items being compared are the same pattern, then this is considered as the first step in the identification process. Next is second level, specific flow of ridges, specific path of accidental features such as scars, subsidiary ridges and flexon creases, etc. The location of ridge characteristics. Identification are comparatively processed on the basis of number of sequence of ridge characteristics. Although ridge characteristics on the subsidiary ridges are sometimes used, the fact that subsidiary ridges appears in two impression is by itself an aspect that could be used in identification process. Fingerprint expert would state that scars and flexon creases are never used in identification process. However, most of the experts agree that they are used in searching and in the initial stages of identification process. All these are aspects of identification process. Most of the experts use number of characteristics and coincident sequences to explain and demonstrate the identification. Next is the third level. Third level detail is small shape on the ridges, that is edgeoscopy, including the ridge unit thickness, thinness and relative pore location, that is poroscopy. Third level detail is always used in agreement with second level. This is the additional aspect that experts are expected to look for. As mentioned, it is used along with the second level. It includes the items mentioned above and adds strength to explain the demonstrate identification and or non-identification with a limited number of characteristics. The expert must evaluate clarity of the print before forming an opinion. Next is biometric performance system. A biometric system can be used as an assistant tool in the forensic scenario for helping on queries against a larger enrolled database. For the query can be helpful to one-to-one or one-to-many search to determine potential matches to a probe forms the gallery, or one-to-one check to verify the identity of an individual. Both tasks are called identification and verification in the biometric research community. In identification, the biometric system searches an enrolled database for a gallery sample matching the probe sample. An ordered list of top n matches may be returned as the possible identities of the probe. The performance of the system in the identification task is measured in terms of rank and recognition rate, which is the rate at which the true association has been included in the top n matches to the probe. Recognition rate is the simplified term for a range recognition rate, where the system returns a single match, the best match, as the most probable association for a probe sample. On the other hand, the verification is a task where the biometric system attempts to confirm the individual's claimed identity by comparing the probe sample to the individual's previously enrolled sample. Verification is based on a decision threshold. The threshold is set by comparing all sample pairs in the gallery. The threshold is chosen to separate the genuine scores distribution from the imposter scores distribution and give the best performance based on the given matrices. First one is false acceptance rate, that is FAR. It is the rate at which the comparison between two different individual samples is erroneously accepted by the system as the true match. In the other words, FAR is the percentage of the imposter scores which are higher than the decision threshold. Next we have false rejection rate, that is FRR. It is the percentage of times when an individual is not matched to his or her own existing template. In other words, FRR is the percentage of the genuine score which are lower than the decision threshold. Then we have the equal error rate, that is EER. It is the rate at which both acceptance and rejection errors are equal, that is FAR is equal to the FRR. Generally, the lower the EER value, the higher the accuracy of the biometric system. Automated biometric techniques can be used to analyze and interpret the biometric traces in the forensic scenario, such as in the investigation of a criminal offense and the demonstration of the existence of an offense. These tasks are usually interrelated with each other. Biometric techniques are used to help in the three main ways. First is decision. In identity verification and identification, a decision needs to be made. Such application includes criminal ID management, suspect or victim identification, etc. Next is selection. In forensic intelligence and investigation, biometric techniques are used to link cases from biometric traces and generate short list of candidates. And the last is description. In forensic evaluation, biometrics are used to describe the evidential value of the biometric evidences. Now, let us summarize what we have learned in this module. Biometric poroscopy, edgeoscopy, is usually concerned with the recognition of a person based on their physical and behavioral attributes. If the epidermis is injured, it regrows very swiftly till the injury has not entered deep into the producing layer of epidermis. The shape of the ridge on the heel surface will be identical with the pattern as it exists prior to the injury. Locard considered pores, that is the poroscopy, which is found on the finger ridges, and they are used in individualization process. He also understood the importance of the form of edges of the ridges, which are also permanent feature like any other ridge characteristics and are also called as edgeoscopy. The size of pores may vary with advancement of age, but their nature and relative position remains constant. Number of pores per unit area can be calculated as the average number of pores that occur on a given length of the ridge or found within the given area. The verification is the task where the biometric system attempts to confirm the individual's claimed identity by comparing the probe sample to the individual previously enrolled sample.